Bugatti's refusal didn't just remove access to parts, it removed the entire safety net that normally exists when rebuilding a hypercar. There was no technical support line to call, no official diagrams being shared, no approved repair procedures guiding each step. Every decision had to be made independently. And that changes the psychology of a build completely. Because when there's no fallback, you don't just follow instructions, you start to truly understand the machine in front of you. That's exactly what began to happen with this Bugatti Chiron. Instead of being treated as a sealed, untouchable product, it was broken down into systems, then into components, and then into individual engineering problems. And once you reach that level, something interesting happens. The car stops being a Bugatti, in the abstract sense, and starts becoming a collection of solvable challenges. Take wiring and electronics, for example, an area most people assume would be completely locked down in a car like this. Modern hypercars rely on incredibly complex electrical systems, with sensors, modules, and communication networks all working together. In a manufacturer-controlled environment, even a small issue here would typically require dealership-level diagnostics and proprietary tools. But without that access, every connection had to be traced, understood, and verified manually. Instead of relying on factory black boxes, the approach became transparent. Every wire had a purpose. Every connector had to be identified and tested. And while that process is slower, it builds a level of understanding that goes far beyond simply replacing parts. It turns the rebuild into something deeper, less like assembly and more like reverse engineering. Cooling systems presented another layer of complexity. High-performance engines like the one in the Bugatti Chiron generate enormous amounts of heat, and managing that heat is critical to reliability. The original system is designed with extreme precision, balancing airflow, coolant flow, and thermal expansion across multiple. When parts of that system are damaged and replacements aren't available, you're forced to rethink how those systems operate. Instead of blindly recreating the original layout, each component had to be evaluated individually. Where flexibility could improve durability, it was introduced. Where flow could be optimized, it was adjusted. The goal wasn't just to replicate factory performance, it was to maintain it while improving resilience wherever possible. The deeper the rebuild went, the clearer one thing became: manufacturers don't always design for perfection. They design for scale. Every part on a production car, even a hypercar, is influenced by cost, manufacturability, and assembly efficiency. Casting is used instead of machining because it's faster and cheaper at scale. Standardized components are used because they simplify logistics. Designs are finalized not when they are perfect, but when they meet a balance of performance, cost, and production feasibility. When you remove those constraints, you unlock a different kind of engineering. One where a bracket doesn't need to be cast, it can be reinforced exactly where it's weakest. One where an exhaust doesn't need to meet a global standard, it can be optimized for a single car. One where even a simple hose can outperform a rigid pipe because it's better suited to real-world conditions. This doesn't mean the original engineers got it wrong. Far from it. What Bugatti achieved with the Bugatti Chiron is extraordinary. The level of integration, the performance envelope, the reliability at extreme speeds, all of it represents the pinnacle of automotive engineering. But it does highlight something important. Engineering is always a series of compromises. And when those compromises are no longer necessary, different solutions begin to emerge. Another overlooked aspect of this rebuild is time. In a manufacturer environment, parts availability can take weeks or months. Logistics, approvals, and supply chains all add delays. In contrast, many of the solutions in this build were implemented in days. A custom exhaust built in 2 weeks. A replacement bolt delivered in 2 days. A hose fitted in minutes. Speed, in this context, becomes another advantage of independence. Without layers of approval, decisions can be made instantly. Solutions can be tested and refined in real time. The process becomes more agile, more responsive, and in many cases, more efficient. There's also a financial reality that runs through the entire project. Hypercar ownership is often associated with extreme costs, not just in purchasing the car, but in maintaining it. Manufacturer-controlled parts pricing can be extraordinarily high, not necessarily because the parts themselves are complex, but because access to them is restricted. This rebuild challenges that model directly. When a structural bolt costs $11 and performs exactly as required, it raises questions. When a starter motor shared with a mass-produced vehicle can do the same job, it reshapes perceptions. When a repaired and reinforced bracket outperforms a factory replacement, it forces a re-evaluation of what original really means. But perhaps the most important takeaway isn't about cost or even performance, it's about capability. This rebuild demonstrates that with enough knowledge, skill, and determination, even the most complex machines are not beyond understanding. They are not untouchable. They are not dependent on a single source of authority. That idea has implications far beyond one car. It speaks to a broader shift in how people approach technology and engineering. The idea that products should be reparable, that systems should be understandable, that ownership should include the ability to maintain and improve what you own. In many ways, this rebuild aligns with a growing movement that challenges closed systems and advocates for greater accessibility. And yet, it also respects the original achievement. Because without Bugatti's engineering as a foundation, none of this would exist. The car itself is still a masterpiece. What this rebuild does is build on that masterpiece, layer by layer, adapting it to a completely different set of circumstances. By the time the car is fully reassembled, something subtle but important has changed. It may look like the same Bugatti Chiron from the outside. It may deliver the same, or even greater, levels of performance. But internally, it tells a different story. A story of problem-solving, adaptation, and incremental improvement. Every modified part carries that story. The reinforced bracket that eliminated a known weakness. The custom exhaust that redefined how the car sounds and breathes. The flexible hose that solved a failure point with simplicity. The precisely chosen bolt that replaced assumption with certainty. The starter motor that revealed how much of the car is built on shared engineering foundations. Individually, each change might seem small. But together, they represent a shift in philosophy, from dependency to independence, from replication to innovation. And that's ultimately what makes this rebuild so compelling. It's not just about fixing a damaged car. It's about redefining what's possible when the usual rules no longer apply. It's about proving that even in a world of highly controlled, highly specialized machines, there is still room for creativity, ingenuity, and improvement. Because in the end, the most important part of this entire build isn't any single component. It's the mindset behind it. A mindset that looks at a closed door and doesn't stop, but finds another way through it. If you liked the video, please subscribe to our YouTube channel.